We welcome you and over to you, sir.
Uh, thank you very much for the nice introduction. So first of all, I'd like to thank management of SNS College for giving me this opportunity to share my views on uh, this forecasting techniques, the work that I have carried out with my research scholars. Apart from that, I will also since this is a faculty development program, I'm also going to talk about various research opportunities that we have in our country. Our institute have been offering, and there are many other institutes also have been working on the various problems. So these are the things that I'm going to cover today in my talk. Uh, I think it is better if we make it more, informal. If you have any queries, you can also ask me in between. Will that be fine, or you want me to cover the talk and then complete the talk and then having question answer session? I'm fine either way. Uh, so, uh, if you permit me to share my slides, may
Yes, sir, please.
I? Okay. So hope you are able to see these slides,
Yes, sir.
right? Okay. So, so once again, thank you very much for giving me this opportunity to share my views on forecasting methods that are being used for solar and wind power. So one of the techniques where we have worked is LSTM-RNN for load frequency control in isolated microgrid. So one thing is I'm going to talk about is load frequency control. Then I'm also going to talk about what is microgrid, and then we will talk about forecasting of solar and wind power. So if you see a present scenario of power system, uh, what is existing today uh, is here in front of you in these slides. As we all know, there has been continuous increase in energy demand across the globe, and also most of the power that is being produced today, not in our country, but yes, everywhere, is through conventional sources of energy. There is pressure on all the governments that these conventional sources of energy should now be replaced by non-conventional sources of energy. So worldwide governments and regulatory agencies are looking on increasing more energy production using non-conventional sources of energy. We all are aware of COP meetings that have been held, that have been happening every year in the globe, in different parts of the world. So government has already committed, our Indian government has already committed that by 2070 we will have net zero uh, emission. So net zero emission means if we are emitting carbon dioxide is equal to say X%, we are going to have similar amount from the renewable. So that though this is going to be very challenging, and time is also very less, because on the other side, if you see, there is continuous increase in demand. So demand of electrical power is increasing, and having them filled uh, by renewable sources is very challenging. So getting rid of fossil fuel based power plants, or you say conventional power plants, is almost impossible. But yes, we can, with the help of technological innovations that are happening across the globe, yeah, these can be minimized. So what are the prime objectives that we as power engineers focus on? Yeah, it has to be economical power generation, it has to be reliable power generation, it has to be of good quality power. But these are the three things, though we try to maintain using power generation from conventional sources of energy. But yes, these three are really difficult to meet when we talk about power from non conventional sources of energy. It is not that economical. You have very expensive solar panels, you have very expensive windmills, or any other uh, technology that you have seen so far is really not very economical if you compare with the conventional sources. Reliability is always a challenge because you do not know what's going to happen to weather next moment. Therefore, reliability is also a major question, right? Another thing is quality. Since it is all non-conventional sources are depending on nature, we know they are intermittent in nature. So sometimes you have sun, sometimes you don't have, sometimes you have a radiance of the level which you want. Next moment you have cloudy weather, you will not have that. So power quality, output of power that you get out of non-conventional sources of energy may not be of that quality. So you need to, address this issue as well. So how country has evolved, I'll quickly go through this, and then uh, we'll go to the topic that I'm focusing on. So India long back had 5 regional grids. We still have 5 regional grids, and but that time we had 5 different frequencies. Each regional grid was operating within that region. And then gradually, where have we reached today is we have one nation, one grid, and one frequency. All the grids, all the 5 regional grids are interconnected to each other. So this is one of the major, you can say uh, some landmark achievements that we have made in electrical energy scenario. So what are the challenges? Okay, we have got to one nation, one grid, one frequency, right? And we say that all the regional grids are interconnected. Then what are the challenges that we face, and why is the need of all these points that I had highlighted in the title? So the challenges are, there are various type of generating sources are coming up. There are various type of loads, non-linear loads are getting into the system. So these are posing challenges in order to maintain quality of power. Quality of power in terms of, if I say voltage, and if I say in terms of frequency. So this is one of the very good example where we say a roller has to move on with a constant speed. So how all generation companies have to balance themselves in such a way that this roller rotates with a constant speed all through, right? And on the other side, if you see, there is uh, on the other side that you see is load increasing, you have generation challenges. So these all are generating companies. You can take this as thermal power plant, you can take this as a hydropower plant, you can take this as wind, we have solar, all of them, right? But they are to be integrated in such a way that overall system remains stable. So this is the major challenge which we have. On the other side, what major challenge that we face, that these, if I say this is solar and this is wind, but both of them are interpreted solely depending on the weather condition. And so a lot of you in fact cannot depend on them fully. So these are also the things which are to be kept in mind. In that case, these hydro and thermal power plant always have to be on the toes in order to maintain the speed of this, or maintain the frequency of the grid. So these balancing act is a continuous process that a power engineer has to do all through. So these are the integration challenges. Now, let me talk about the topic of the day, where we are going to talk about forecasting of solar irradiance and wind speed data. But why? Why do we need forecasting? So why forecasting is needed can also be explained uh, through this microgrid architecture. But in general, those who are new into this domain and attending this talk should understand that suppose you have a certain load, right? That has to be met with 5 different generations. If I have good forecasting techniques, I don't have to worry about thermal, I don't have to worry about hydro, because I know they are controllable sources. If I know they only these are two produce X, they can. But since in order to make the system greener, I have added solar and wind. If somehow I get a good forecasting, say, or at least an hour before, or at least, I mean, better if I get a day ahead uh, forecasting with almost no error, I would be very happy. If I know from 3 p.m. to 4 p.m. this is going to be cloudy, I know power will drop down to this value. I have to boost my thermal generation in order to meet the load. So if that level of forecasting is achieved, we will have very stable and very reliable system. Because weather is intermittent in nature, we have to rely on forecasting in order to make system more robust and reliable. So therefore, forecasting is needed. A lot of techniques. It is not new. First thing, it is not new that forecasting is being done. We all know we have been using our smartphone. We know what is going to be temperature tomorrow or after 15 days from now. But yes, as you see, the moment we approach to that particular hour, say half an hour before, then only we are able to get the almost certain prediction. We do not get even a day before the exact prediction that is there, right? So there is always a variation. So these are the things which make system little fragile. So in order to make it more robust, we have to develop certain uh, on the basis of available data, we have to develop certain techniques which can forecast, or techniques which can forecast these I mean uh, forecast solar irradiance, wind speed throughout the day, at least a day before, right? That will help us in optimizing the scheduling of our hydro and thermal power. So therefore, this is needed in general when we talk about national level grids and other larger system. When we talk about microgrid, but what is microgrid? So I quickly tell you what is microgrid. Because these techniques are fine. I mean, today our own code we have put up there on GitHub for others to use, because we don't never wanted to keep it with us. We want people to make best use of it and make it more better and use for uh, their own work if it is possible. Sorry. So uh, this what is microgrid? So microgrid is a smaller grid where a smaller electrical network where you have all type of loads and various type of generating sources. So generating sources, when I'm talking about a smaller grid, definitely there is no thermal power plant, no hydro power plant, and mostly the source of generation would be renewable source of generation. If you see what is microgrid architecture, so if you see the architecture, you have solar, you have wind, you have battery energy storage, you have different type of loads, you have electrical vehicles coming in, you have different type of other electrical loads, you have building loads, you have obviously houses, factories, everything is considered as load. So in when I talk about microgrid, this is all what what you have in the microgrid architecture. But it will be depending on various factors. It will depending on weather forecasting, right? Because sources, as I said, are thermal. Sources, as I said, are renewable. So renewable, you have solar, you have wind, you have battery energy storage, and all type of linear and non-linear loads, right? So weather forecasting is going to play a major role in predicting their generation, right? And it will also be depending on other microgrids which are associated with it, which could be interconnected, or if they are not interconnected, but yes, maybe connected to this microgrid. And obviously energy market, though this is going to be altogether a new topic. I'm not going to talk about it because this is going to be a separate, it could be a separate talk and discussion on it. So energy market is also one which in time to come uh, will help us in, you know uh, buying and selling power, which mostly, if some of you might have heard of peer-to-peer energy trading. So that could be a possibility in time to come when this microgrid system evolves. So why microgrid system is going to be evolved? Government of India and other governments have been talking about smart cities. So when they talk about smart cities, so it has to be smart in all the ways, not only in terms of having good transportation, good roads, but it should also have optimal energy management, right? So that is also one of the major focus of smart city mission. Though very few cities have been focusing on overall energy management, mostly the current focus of making the cities smarter is through, bringing in basic infrastructural changes in terms of, public transport, in terms of road conditions, in terms of cleanliness and other things. But optimal energy management is going to save not only money but also making overall environment of that city greener. So this is all about microgrid. Microgrid will also have definitely a feature. If you see this whole system, this hope, am I audible, right?
Yes, sir. Audible only, sir.
Yeah. Okay. Thank you very much. So this whole system is the microgrid, and microgrid can work in isolation if we have sufficient energy storage with us. Uh, Otherwise, also it may or may not be connected with grid. So we always have this point of common coupling, which has this which gives us this flexibility of connecting ourselves, I mean the microgrid, to main grid in case of emergency, where you don't have solar, you don't have wind, battery energy storage exhausted, then we will have to definitely take power from the grid. So therefore there is going to be a connection, but may or may not be used. uh, so this is another thing. Why do we need these distributed generation? I mean, solar, wind, and other things. Because conventional power stations are centralized and often require electricity, as we all know, to be transmitted over long distances. Right? We don't have a power plant in the city where we live. Would be at a very far distance. So these things would actually are forcing us, to go for microgrid structure, because that gives that in fact helps us in optimizing better energy, uh, optimizing better energy management, and also giving us a greener energy solution. Therefore, there is a need of distributed, I mean, segregated generation systems. So you'll have solar plant, wind, but all of them, in the vicinity of the load. Another thing that I also missed, but all of them are also connected to, controller, where you have every information getting stored, and you have algorithm, which is, so these dotted lines are all the information, in fact, or communication links you can see, which are being fed to the controller. Later, this controller with the algorithm in it is uh, giving the information back and taking some decisions about overall load management and generation management. Okay, so next is what we have been talking about, what we have done. We'll just quickly go through some of the results and uh, uh, some results and the data. As I've already said, that it's not now when you search not our code, but you will find so many other codes on GitHub for us to use. So we have also put up our code there for others to use. So this is just about uh, forecasting methods. So time series forecasting of solar irradiance and wind speed has been tried with different approaches. One is the statistical approach. This is also known as SREMA. Another is, people have been talking about machine learning, deep learning. So these are also the new things which are coming up, where we have been developing algorithm in such a way that system itself, with the data available, it is making decisions, right? So long short term memory neural network based system are used for uh, forecasting, right? So, but forecasting would be on uh, of solar irradiance and wind speed, because if we are aware of solar irradiance, we know how much power would be generated. If we are aware of wind speed, we can directly calculate the total estimated power that it can generate. So therefore, these are the two things. We don't have to directly calculate solar power prediction. We don't have to predict solar power directly, or we don't have to predict wind power. But these two, a natural, you can say, input to these non-conventional sources. So, so these are the, results. Only I'm going to show you the best results that we have got. So this is the actual wind speed, right? The actual wind speed. And I just quickly want to tell you that we have got this data there. Now you have so much of data available. You don't have to, rely on, uh, you don't have to go to any place. But since we were doing this research, we thought of approaching some agencies, and we got this data. So now on online, there are multiple sources from where you can take uh, solar irradiance data of the location where you are, right? So this is as not that difficult in today's time, right? So we have wind speed. So what I'm saying is, we have wind speed here, and this is the actual one, and this is the one which is forecasted. Similarly, it is also there with solar irradiance, and this is forecasted. So both of us, both are very close to each other. But when we further went for, LSTM model, so in LSTM model, when we did this, we found very interesting, results. If you see the results that we have got for solar forecasting, so the results that we have got is so close that root mean square error is just 11% here, but yes, here we have overall LSTM with this RNN which we used, we have got RMSE, root mean square error, is just 4.45. I mean, our output and the actual value were very close, right? So these are the things which we have compared. I again repeat, this is just on done on a simulation at the simulation level where we have got such a close, results. But since data was actual and we had almost every 15, the data that we had was of every 15 minutes. That is another thing which also I want to focus. Then when you ask for data, you may be getting per day data, you may get on hourly basis data. I mean, whatever you want is today available. So what do you take? Better the data you have, output is going to be definitely better. So solar irradiance, what we proposed from the proposed method, is going to be very uh, good, is almost equal to the actual value that we compare. But another thing that is there, it is just, you know, this is predicted only for an hour, right? But what and how, what to what level that this has to go is that this has to go that we should be getting almost same RMSE, same error, almost nil error. In fact, that is ideally what we expect when we do it for the day, right? If the day when we will achieve that, then we can say yes, we have got to the best of forecasting method. So in simulation, since we did even 1 hour, 2 hour is good enough, because you can plan accordingly. Because if you know after an hour there's going to be cloudy weather, you will be able to manage the things. Uh, but would be best if we get at least a day before exact prediction, right? So these are the challenges everywhere we have, wherever this non-conventional sources of energy being used. So here the crux is that there are various methods of forecasting. There are various machine learning based methods. People have used various modified version of neural network, which is named as machine learning, deep learning, intelligent learning. There's so many things are coming up. So ultimately all of them are doing what? They are training the data. The better the training you have, output is going to be better. So these are the things which I wanted to show in terms of forecasting part. Since this is a faculty development program, this is one thing which you can definitely explore, and these codes are available, as I said, everywhere. You don't have to, restrict to, or don't have to ask anyone today. You have GitHub available where you can take the code, you can modify that and do it, since we also developed one and put up there for others to use. So this uh, since this is faculty development program, I also want to bring the attention of other researchers, those who have been planning to do their PhD, because some of the faculty, or those who have already done their PhD, they are exploring new things to be done in this energy domain. Then we have also been working on application of IoT in power system. So what are the different applications of IoT in power system? I just quickly tell you the example of our own work where we have developed IoT based energy management system for a microgrid with vehicle to grid feature. Right. Hope you all understand what is energy management system. Now you all know what is microgrid. So here, when I talk about vehicle
Hello, sir. Sir, can unmute the mic, sir?
Oh, I'm sorry. So you didn't
Okay, sir.
hear me?
Yes. Yeah, now
I
it's audible, sir.
this is fine. I mean, uh, was it unmute for a very long time?
Yeah, no, sir. Now only, sir.
Okay, okay, fine.
Just now, sir. Okay, okay.
Okay, okay, fine. Right. So the slides are visible. Slides are visible.
Yes, sir, it's visible only, sir.
Okay.
Okay.
So, so what I'm saying is IoT based. So we all know what is energy management, what is microgrid. So here I'm referring to electrical vehicles. So today, when I say an electric car, so approximately electric car, 30 kilowatt. I'm not talking about Tesla in that range, but a normal car, 30 kilowatt hour, 40, 50 kilowatt hour. So you can imagine there are 30 units stored in that car. There are 50 units stored in that car. If 50 or 100 cars are parked in the parking of a mall, so you can imagine how much power is stored already there. And to go back home, I just need little power. So if I can give back that power to grid to support that mall to run, I get in turn I get uh, some financial incentive, or could be or incentive in of some other kind. uh, Definitely, that is what is going to make electrical vehicle more useful. So we have worked on IoT-based energy management system, where we developed a microgrid here in our campus. We don't have wind, obviously, battery energy storage system, and solar PV. So we have a lot of data available with us. So today we are not relying on for forecasting. I'm also going to link the same here because that is important to learn. See, these things, if we do on simulation, it's fine. You get better result, you get a publications. But how ultimately a system or or a society getting benefit out of it? So society should also be benefited out of the work that we have been doing. So this should not only limit to one or two journal or good conference publications, but should ultimately be translated into the form of a product, a form of a new process. So I'm just going to give you a quick example of what we have done in our campus and has been running successfully. So this solar panel, you have a battery energy storage system. Obviously, we don't have wind, but since we wanted to depict here a microgrid, we have it here. So this is a microgrid which we have developed, solar-based intelligent microgrid having battery energy storage system. So instead of lithium-ion battery, because that is going to be very expensive, and we did not have a space constraint, we went for lead-acid batteries. Right? We have EV charging stations. So these EV charging stations are that we have designed is for two-wheelers, uh, and it has capability of communicating with both ways. So this is just the information that we have been getting, how much power that this vehicle requires, and you have that proper communication channel established. So every information that we want is coming to us. Now, another thing is, from charging stations, we have got an EV aggregator with every information that how many vehicles are there require charging, how many vehicles are there who are ready to contribute in terms of selling power back. So this is called EV aggregator, which, so since we are talking about electrical vehicle, So therefore, since you have it in battery, may so that battery power should also be ultimately immediately be used, because you don't have any other storage option here. So in that case, there has to be a controller who gets every information about all the vehicles, whether they are able to contribute, and whether system really needs that power or not. Because it may also be possible that system doesn't need power, but you have a car who is willing to sell the power. So this will have some mechanism where this would ultimately be stored in battery energy storage, or it would be, yeah, it would be used directly, right? So this is whole loop which functions, right? And what have we developed in our campuses? We have developed a microgrid where you have solar based charging, and implemented, since we get data on the real time basis after every 5 minutes, we our own this LSTM based, only LSTM based algorithm, and we are able to predict what is going to be there tomorrow. And that prediction has helped us in saving electrical power. Saving is from solar panel, because we don't take any power from the grid. And during night time, because this is installed on a, within our campus, there is a supermarket that works from 9 a.m. to 8 p.m. So from 5 to 8, it is on battery energy storage system, right? So so this is what we have already developed, and forecasting is helping us in predicting the weather tomorrow. So how much solar power that we are going to generate, whether we'll have to take power from the grid or not. So we have saved our electricity bill. Obviously this solar is designed in such a way that it has capability of catering the full load of the market. So we have reduced our electricity bill to 82%, right? Last year, if you see from April to March. So this is a big saving. Additionally, we have electrical vehicle charging, which we give them for free, because just for two-wheeler charging, people come and charge the vehicle because it is solar power based. And during nighttime, it is on the battery. Since it is two-wheeler, it doesn't stress the network much. So this is another approach that we have also been proposing and currently working on. So battery energy storage system, so the microgrid and this, uh, so battery energy storage system is going to help in charging the vehicle, uh, and there would always be a possibility of discharging if you want them to discharge it to. It could be any battery energy storage system, or it could be directly to the grid. So these are the things which is there. Another so another system in terms of electrical vehicle that we have been working on now, you can see there are a lot of companies have already established this, but we have been doing in one of the most economical and very optimal fashion this battery swapping system, where probably this could also be seen as those who have some inclination towards entrepreneurship. They can think of such system for uh, you know such system as a new business model, right? So what I'm proposing here, that we will have solar or wind, whatever, I mean, non-conventional sources installation at very, off the site, at far off place where you have plenty of solar, plenty of wind, government giving a lot of subsidy, uh, and installing there. So that power, solar plant and wind plants are of that particular company, feeding it to the grid. And you have across the city, you have various battery swapping stations, right? There you have multiple batteries stored of all kind of vehicles, and all of them would get charged. When a vehicle comes, right, you can easily replace the old batteries, and it would be paid through an app. So we have also developed, but we are not exactly swapping currently. But yes, the app and other things are ready with us. And because batteries are of different types, it's very difficult to actually operate such system. But this could be a business model for those who are planning to venture into such uh, businesses, because this saves. Today, where is the focus? Focus is on developing charging infrastructure in the country. No matter how fast you do, but it will take at least half an hour, 1 hour if it is car. Even if it is very fast charging, it will take 15 minutes for two-wheelers. So since it is going to be 15 minutes for two-wheelers, you just can't afford that, right? So in order to bring it down to just 2 minutes, this could be a solution, right? Battery swapping system could be a solution, though it is now there in only very selected cities. You take example of Chennai, you have in Bangalore, Hyderabad, Delhi, Noida. But this could be, if such model where all the batteries getting charged from renewable power, because you today the government regulation says no matter where you have, but wherever you are producing electrical power will be fed, and you can take the same, you can draw the same amount of electrical power uh, from the grid at different locations. So this is all the batteries that you have in battery swapping system is fully green. They are powered by green energy. So this is another, this has a business angle. This can also be a new research angle. This is definitely could be could also be, if you bring in some new uh, innovations in design, this could also be a new uh, a patent, or could be a new technology that has technology transfer capability. So these are the things which are also there for other researchers to explore. So that's all I have here for you to discuss about. But yes, if you want any data, it's available. If you want any code, we don't keep anything with us. We put up there on GitHub and at other places so that others can also use. Uh, I mean, this is the currently our research domain where we have been extensively working. So we have a team of research scholars, master's students, and there are some good undergraduate students who have been helping us in developing this model. So this is one. Another is peer-to-peer energy trading. As I just said, the energy market is not that much, there in the country today in terms of microgrid. But yes, in time to come, when you have full-fledged smart cities developed, these are the things which would be very much relevant. So that's all from my side. So thank you. Thank you very much.
Thank you, sir. Like I have a question, sir. Is there any
Yes, sir.
specific reason for choosing LSTM algorithm for wind forecasting?
Right. So there is no specific reason for this. But at that time when we were doing, ultimately, how do you judge that the forecasting method that you have used is good or bad? So whenever we got better RMSE, the root mean square error, I mean, you can also calculate other errors. uh, these this LSTM gave us best results, is the reason we stick to it. But there is absolutely no end to it. There are, if you recently, I mean, just 4 days back, when I was just going through some techniques, so people have used advanced machine learning algorithms in forecasting, where they say they predict that almost full day prediction with almost 3 or 4% of root mean square error, which is really excellent. So that was the reason. I mean, since we wanted to explore new techniques which are based on neural networks, we went for this. Otherwise, yes, there are many new methods coming almost every day, which can also be explored.
Okay. Sir, is there any formula to arrive at the number of hidden layers or the number of neurons that we consider for LSTM?
Right. So, so there is as such there is only idea that we did, and all these values that we chose was on the basis of see, we had training data. We had data which was to be fed to this so that it gets trained, right? So there is as such no formula. More hidden layers you have, ultimately you are going to get better results, right? So this, there is absolutely no formula where I say if you take X number of hidden layers, you are going to get this result. No, absolutely not. Every time when we did, we got a different RMSE. So there is absolutely no as such straightforward formula which I say you use this, it would work. No, one has to explore this again and again. As you know, better you train, uh, uh, better the results be.
Okay.
Right.
Thank you, sir. Thank you so much for clarifying my doubts. Like participants, do you have any queries to ask? Okay, sir. Thank you so much, sir.
Thank you. Thank you
For
very much.
enlightening us with this deep learning algorithm for forecasting.
Thank
Right.
you.
Thanks for accepting our invitation, sir.
Thank you. Thank you for
So,
inviting me. In fact, it was pleasure to be here.
yes, sir. Thank you. Right.
Thank you.
So
Bye-bye.
we can end the session, sir. Thank you.
Thank you. Thank you.
Thank you, sir. Shall we ask to on the video?
Yes, ma'am. We shall take the photographs. But the number of participants are quite less.
Yes, ma'am. Shall we
We
Ma'am,
take
can
the
use the
6:30?
okay, ma'am,
சொல்லுங்க
can
sir.
take photo at 6:20, ma'am. 6:20 or 6:25?
6:30க்கு நம்ம வச்சுக்கலாம் சார் போட்டோ எடுக்கிறது.
Yeah, okay, ma'am.
6:30க்கு போட்டோ வச்சுக்கலாம்.
Photo முடிச்சதுமே this link will be posted in the chat box.
ஓகே. அப்போ 6:30க்கு எல்லாரையும் ஜாயின் பண்ண சொல்லணுமா?
Yes, ma'am.
இப்போ டெஸ்ட் போட்டுறலாம் சார். இப்போ டெஸ்ட் போட்டுறலாம்.
Okay, ma'am.
இப்போ டெஸ்ட் போட்டுறலாம்.
இப்பவே ஆன் பண்ணாங்கன்னா எடுத்துறலாம்.
இல்ல 114 அட்டெண்டன்ஸ் தான் இருக்காங்க.
Around 6:30க்கு தான் almost participants.
மேம் இப்ப இருக்கிறவங்கள எடுத்துட்டு 7:30க்கு ஜாயின் பண்ண சொல்லலாமா இல்ல 6:30க்கு?
அப்ப 7:30க்கே ஜாயின் பண்ண சொல்லிடலாம் சார். லைக் டெஸ்ட் லிங்க் இப்போ போட்டு விட்டுருவோம். 7:30க்கு நம்ம போட்டோ எடுத்துடலாம்.
சரி, ஓகேங்க மேம்.
இப்போ டெஸ்ட் லிங்க் போட்டு விட்டுருவோம் சார். டெஸ்ட் லிங்க் வந்து ஆக்டிவா இருக்கட்டும். till 7:30 வரைக்கும் ஆக்டிவா இருக்கட்டும்.
சரி, ஓகேங்க மேம்.
ஓகே சார். Participants, the test link will be posted in the chat box. You can take up the test. You need to score 70% of 70% to get the certificate. So we have enabled multiple attempts. If you don't get more than 70 marks, no, you will not get the certificate. So you can try as many times possible till you get 70 marks. No, you can try attending the test. And we shall rejoin at 7:30. 7:30 we can have our valedictory. I request all the participants to join, because no, The registration is around 180 and we hardly see 130 members only attending regularly. So I kindly request all the participants to join at 7:30 without fail, please.
Ma'am, Aarti ma'am, can you hear?
Yes, yes.
Ma'am, what will be visible to us? Hello, ma'am. Aarti ma'am or Mani sir, can you hear me?
Yes, yes, ma'am. You're audible. Please tell me.
Oh, ma'am, whether the mark will be visible to us?
Yes, we can make it visible.
Take multiple attempts. So, do we have
Yes.
the chance of knowing our marks?
We'll make it, ma'am.
Yes, ma'am. Thank you.
Testing, madam.